Good day out there. You are welcome to Science Explained. This is the continuation of the topic mole concept. In my previous videos, I discussed mole concept in terms of relative molecular masses or relative atomic masses, depending on whether it is a compound or a gas. Followed by mole concept in terms of Avogadro's constant, which is a number 6.02 times 10 raised to the power 23 per mole. Today, I want to have a look at mole concept in terms of molar volume. To start with, what is the definition of molar volume? Molar volume can be defined as the volume occupied by 1 mole of a gas. 1 mole of a gas at standard temperature and pressure. Meaning that it cannot be more than 1 mole. And that 1 mole is equivalent to the molar volume of that gas, irrespective of whatever the gas is. The value for molar volume is 22.4 dm³, which can be converted to cm³ by multiplying by 1000. We get 22,400 cm³, meaning that 1 mole of any gas will occupy this amount of volume at standard temperature and pressure. What do we mean by standard temperature and pressure? It means the temperature and pressure used to measure the standard value of any substance. And the standard temperature is 273 Kelvin, while standard pressure is 760 millimeter mercury. Now, these are example questions on mole concept with respect to molar volume. Do not forget, molar volume is applicable to only gases. It's not meant for either solid or liquid. Now, look at the questions and give it a try before I come in to solve it together with you. At the end of this class, if you find it interesting, please do not hesitate to subscribe to my channel for subsequent videos. Share it and like it. Thank you. Alright, the first question can be solved this way. Calculate the volume occupied by 3 moles of carbon 4 oxide at STP. Now, carbon 4 oxide is a gas. There is no iota of doubt about that. And we are given 3 moles of it. And we are given in the bracket here that GMV, that is gas molar volume, is 22.4 dm³. According to my previous explanation at the beginning of this class, I said, and I repeat, that 1 mole of a gas is equivalent to 22.4 dm³ at STP. So, if 1 mole of a gas is equivalent to that, definitely, how many volume will 3 moles be equivalent to? This is now mathematical. 3 moles will be equivalent to, let's say, x dm cube. Draw a division line between the two sides. Ensure that mole and mole are on the same side, volumes and volumes are on the same side. Then cross multiply and make x the subject. So when you cross multiply, x times 1 will be equal to 3 times 22.4. So x times 1 is x, and 3 times 22.4, that will be 67.2 dm cube. 67.2 dm cube. That is the volume occupied by 3 moles at STP. That is about question 1. Example 2 question. Determine the number of moles present in 11.2 dm cube of nitrogen 4 oxide. This is the chemical formula for nitrogen 4 oxide, NO2, at STP, standard temperature pressure. GMV, gas molar volume, is 22.4 dm cube. Now, how do we go about it? If you look at this question critically, you see that you are being asked to find the number of moles now. You are not given, you are asked to find it. The number of moles you are finding is the number of moles present in 11.2 dm cube. That means you are given the volume. All right. So first and foremost, the first thing you should do in cases involving mole and molar volume is to relate 1 mole to the molar volume. First step. 1 mole is equivalent to 22.4 dm cube. Now, we are looking for the number of moles. This time around, I will use Y mole because I want to assume Y is the value of mole I'm going to get. Will be equivalent to 11.2 dm cube because that is the number of moles we are looking for inside of this. So 11.2 dm cube. Then what do? Draw a division line between them. Ensure the arrangement is okay. The moles on the same side, the volumes on the same side. It can be either side, but you cannot mix it up. So all the moles must be on one side, all the volumes must be on one side. So you cross multiply. When you cross multiply, what do you get? Y times 22.4 will be equivalent to 11.2 times 1. Divide both sides by 22.4. So this cancels out. Y will now be 11.2 over 22.4. Let's use the calculator to get our value. .5 mole. That means 0.5 mole of gas nitrogen 4 oxide is present in 11.2 dm cube of that same gas at STP. Now let's move on to the last example question. How many grams? Take note, we are asking, the question is asking us to find grams. And of course, we know that grams has to be for mass. Of gas are present in 5,600 cm cube of chlorine gas. So we are particular about the gas now, which is chlorine. So what do we do? Like I told you, 1 mole is equivalent to 22.4 dm cube at STP. But since it is not mole we have to find, it is grams. That means I will advise you convert 1 mole of chlorine to mass, to its relative atomic mass first, so that you won't get it wrong. Or maybe at the end of the calculation, after you have gotten your mole, you can convert it to mass. Either way. Okay, since I've been using mole all this while, let me use mole. Then after finding the moles, I will convert it to grams. Now, 1 mole is equivalent to 22.4 dm cube. But since this is given in cm cube, I will convert this also to cm cube, or I convert this to dm cube, either of the two. It's either I convert this to dm cube or I convert this one to cm cube. But it's better I convert this one to cm cube. Why? Because the question gives me the volume in terms of cm cube. That means I should be able to leave my answer in terms of cm cube. So, which is the same thing as 22,400 cm cube. That is 1 mole. So, let's say X mole now equivalent to this 5,600 cm cube, because we don't know the number of mole in this. 5,600 cm cube. Alright. As usual, I will draw division line between them. Cross multiply x times this. X times 22,400 equivalent to 1 times 5,600. Dividing both sides by 22,400. That means x will now be 5,600 divided by 22,400. What will that give us? Let's have a look at that. 5,600 divided by 22,400. That's 0.25 mole. 0.25 mole. Now, we have been able to find the number of mole present in 5,600 cm cube. But do not forget, the question is asking about what? Grams. That means, what next? Convert this to what? Grams. By using one of our previous information in the previous videos. Recall that mole is equal to mass over relative atomic mass. So that means, what is relative atomic mass of chlorine? That will be 2 relative atomic mass of chlorine will be 2 times 35.5, which is 71. Why is it 71? Why is it multiplied by 2? Because, reason, 1 mole of chlorine, 1 mole of chlorine is Cl2. That is, it contains 2 atoms of chlorine, because chlorine is a diatomic element. So 1 mole of it is Cl2. That is why I have to use 2 to multiply. That's 5.5. So going back here, that means mole, which is 0.25, equals the mass we are looking for over the atomic mass, which is what? 71. So when you cross multiply, mass will be 0.25 times 71. And what does that give us? (17.75). 17.75 cm cube. That is our answer for the last question. Now, in my next video, I am going to deal with application of mole concept. In which area of field of chemistry can we apply mole concept to solve problems, especially experimental problems? I will be discussing this in my next video. Please do not miss it. Subscribe, share, and like the button. See you next.